By creating new technological solutions for industrial activity, we promote the change to a low-carbon society. Innovations that utilize industrial side streams are an example of an industrial-scale environmental accomplishment. The competition aims to increase students' understanding of the challenges of an industrial circular economy and help them to develop sustainable solutions for industrial side streams through new product and service innovations. In previous years, the competition has been held with Finnish students. Tapojarvi wanted to grow the 2023 competition by working together with EIT Raw Materials. EIT Raw Materials' mission is to support securing the supply of critical raw materials to the European industry by driving innovation along the raw materials value chain. This year, the central theme of the competition is the utilization of side streams from 3 industries: steel industry, mining industry, and forest industry. Student teams around the world have created their own product and service innovations around these themes. The competition received applications from a total of 29 teams from 14 different countries, from 22 universities, with a total of 71 students, representing 43 different nationalities. The experts of EIT Raw Materials selected 21 applications for the competition, which were evaluated by Tapojarvi's panel of experts. 5 teams were selected for the final after the first round. Today, the finalists will present their innovations to an international jury. Fernando Camponi, Mikko Hyytinen, Lawrence Lam, and Henri Pilvente. The 3 best innovations will receive a cash prize of 15,000 euros. In addition, the winning team's innovation may be developed into a sustainable circular economy service product at Tapojärvi. Finalists, good luck for tonight. Welcome to the Innovation Challenge 2023.
Good afternoon all, and welcome to Tapojärvi Innovation Challenge. My name is Mari Pilventö, and I'm the acting CEO of Tapojärvi. I am hosting this wonderful event with Prestige Mauri Kauppi, who is a member of Tapojärvi board. This year, the central theme of the competition is the utilization of side streams from 3 industries: steel, mining, and forest industry. As usual, students pitch their ideas to the judges, and the best idea wins. This event also marks the birthday of our beautiful company. So, happy 68th birthday to all Tapojärvi people. So, Mauri, it is the 3rd time we celebrate Tapojärvi birthday on this stage. And soon we will hear some great ideas. What are your expectations for tonight?
Thank you, Mari, for your kind introduction. Well, what to expect? That I know that a lot of good work has been done since the first round was done, and looking forward to see what we will see within today's presentations. This year we decided to make this with a partner, and we selected EIT Raw Materials to do the job. Since we are sharing the same targets, their mission is to help securing critical and strategic raw materials inside European Union, as well as promoting innovative solutions. This nicely fits our strategy as well. On top of that, we have another goal, since this is the 3rd time that we are standing here, to make this occasion more international. And indeed, this is what we have achieved. We have shortlisted the big number of applications to 5 now, basic criteria being that we can see some potential possibilities, as well as that the applications are somehow fitting to Tapojärvi. So all these 5 teams are here today.
Our first specialist, the HSE manager of AST, Mr. Fernando Camponi, is attending via live stream. Buongiorno, Italia.
Good afternoon or good morning, I don't know the time in Finland, but I'm very happy for your invitation and the second time for me to be part of the jury. I'm very proud to be may give my small contribution for the professional growth of young people that surely I can be able to show their knowledge and their entrepreneurs tendency. Thank you.
Mr. Camponi, this is your second time as a judge, and you have seen the material of this year's students. How has the challenge developed, in your opinion?
They are very, very well focused on the target that you gave to them, and in general, they are very multi-purpose approach without neglecting also the economical and financial part is very good for me because I'm an engineer, so I'm more expert about the technical issues, but I appreciate very much the fact that they can give an overview also from the financial side of the project. So I appreciate very much.
And then from Outokumpu, we are glad to have Mr. Mikko Hyytinen, Head of Business Excellence, Business Area Ferrochrome. First of all, glad to have you here.
Thank you very much.
Another good thing what we have been reading from Outokumpu is that you have set an ambitious target, making Kemi mine carbon neutral already by 2025. Can you explain a little bit about it?
Yes, very, very happy to do so. So we have set ourselves a very ambitious target to be carbon neutral by the end of 2025. And the first step that we have now already taken is that we have started to use renewable fuels in our machines and also in concentrate transportation. And that has brought us already down by 30%, almost 1/3 of the total CO2 emissions at the mine.
Okay, thank you.
From EIT Raw Materials, we have Senior Advisor Lawrence Lamb. You have been selecting today's finalists from a big group of ideas. How do you rate the level of the competition?
So thank you first for the invitation. Very happy to be there. We had a very good and technical content also, considering that they are in technical path, adding the economical plus the marketing was really very impressive from this side. I would like also just to say that almost half of the students are coming from EIT Raw Materials Label program. And you can see here, obviously, that what they learned during their courses is directly applicable for an industrial. So it's a very good sign.
Thank you.
Thank you.
Okay, and last but not least, we have Chief Commercial Officer, Mr. Henri Pilventer from hosting company Tapojarvi. Welcome to the stage as well, to be part of the jury.
Thanks.
Well, Henri, you heard already Mikko's very ambitious targets in Kemi mine. Is there something what we can do for them to ease their way towards their target?
Of course, firstly, I'm very glad to hear this very ambitious goal. And of course, we as a service provider want to do everything we can do to help our client to reach that goal. So yes, we are already doing some things like Mikko already mentioned. And of course, in the future, we would like to be part of the team to create the carbon free.
Okay, thank you, Henri. Tapojärvi has had since a long time an established position in the service provider for industrial and mining purposes. But alongside the years, we have been investing heavily on circular economy as well. And we have a prime target for the future to become #1 in the world as a industrial circular economy provider. That is a great target. We are going to watch a brand video of Tapojarvi, where actually we are opening up how we are going to achieve it and where we are going to focus in the next coming years.
Itse kun on isä ja haluaa, että lapsillekin jäävi jotakin muutakin kuin niitä jätevuoria, niin lapsille pyrkii opettamaan, että kaikkea pitää kierrättää, niin miksi ihmiset ei kierrättäisi myös tuolla isossa teollisessa mittakaavassa?
Sivuvirtoja, jotka päätyy jätteeksi, että jos niitä ei käsitellä ja niillä ei löydetä uusia käyttökohteita, niin sittenhän nämä 1000 tonnit ja miljoonat tonnit päätyy luontoon. Se ei tunnu hyvältä ajatukselta ja se ei ole kestävää eikä vastuullista millään tavalla.
Ja siihen me tähdätään, että jätteitä ei syntyisi niin kuin ollenkaan, että saataisiin niin kuin kaikki tuotteistettua.
Me ollaan Tapojärvellä oltu pitkään palvelutuottajia ja me ollaan nähty näitä mahdollisia sivuvirtoja ja ollaan huomattu, että siellä läheskään kaikkea ei hyödynnetä niin kuin niiden potentiaali antaisi mahdollisuuden.
Tapojärvihän keskittyy ensisijaisesti terästeollisuuden, kaivosteollisuuden, puunjalostusteollisuuden sekä elektroniikan romun käsittelyyn ja hyötyaineiden talteen ottamiseen.
Tällä hetkellähän meillä on useampi eri rikastamo, missä käsitellään terästehtaiden kuonia. Kuonahan on semmoista sivuvirtatuotetta, jossa on arvokkaita mineraaleja, metalleja ja meidän hommana on sitten ottaa ne mahdollisimman tarkasti talteen.
Teräspuolella voisiko sanoa, että kiertotalouden ehkä paras esimerkki on Tornion terästehdas, jossa 95% käytetään kierrätysterästä.
Tapojärvi on kehitellyt erilaisia sementtejä, joilla pystytään korvaamaan nykyään käytössä olevaa perinteistä sementtiä ja tämän hiilijalanjälki on paljon pienempi kuin nykyään käytössä olevan perinteisen sementin hiilijalanjälki.
Kaivoksilla kun joudutaan sivukivikasoja peittämään, siihen olemme kehittäneet geopolymeerin, jossa me voimme käyttää kuonia. Kun mennään vielä vähän asteita eteenpäin, niin meillä on sitten näitä tuotteita, jotka voi käydä kemian teollisuuteen, jopa kosmetiikkateollisuuteen, elintarviketeollisuuteen, hyvinkin monen käyttötarkoitukseen.
Meillä on 20 ihmisen asiantuntijaryhmä, jota me kutsutaan kehitystiimiksi, ja heidän tehtävänä on löytää erilaisia ratkaisuja sivuvirroille ja jätteille eri teollisuuden aloilta. Ja sitten kun me löydetään joku tämmöinen idea, joka tuntuu, että tämä on nyt tarkemman tutkimisen arvoinen, niin sitä aletaan testaamaan ensin pienemmässä mittakaavassa laboratoriossa, sitten vähän suuremmin pilottina ja sitten täyden tuotannon skaalauksena, jonka jälkeen se on valmis kaupallistettavaksi.
Esimerkiksi teräskuonan käsittelyt tuolla Italiassa. Cernin laitos toimii keskellä kaupunkia, eikä ole tilaa läjittää näitä raaka-aineita enää yhtään enempää. Niin olemme sitoutuneet siihen, että me ratkaisemme nämä paikalliset tilaongelmat plus sitten myös se, että saadaan nämä tuotteet oikeina tuotteina markkinoille.
Jokaisella tehtaalla, kaivoksella, siellä on omanlainen systeemi ja omanlaisensa laitteisto. Ja se on räätälöity ja viilattu sitä varten, että juuri siellä sen saitin materiaali, niin se saataisiin mahdollisimman hyvin talteen.
Tapojärvi on avaamassa uudelleen vanhaa Rautuvaran kaivosta Kolarissa. Kaivoksen uudelleen avaaminen on tärkeää siksi, että siellä on edelleen jäljellä hyödyntämättömiä varantoja. Ja jos ajatellaan vaikka huoltovarmuutta, niin ne kuparivarannot, jotka siellä on merkittävässä roolissa meidän tulevaisuutta ajatellen.
Jos ajatellaan akkumineraaleja, niin Eurooppa on hyvin pitkälle tuontiraaka-aineen varassa.
Kaivosteollisuutta itsessään ei monesti mielletä oikein yhteenkuuluvaksi kiertotalouden kanssa.
Se, että vanhan kaivos avataan, niin on omalla tavalla jo kiertotaloutta.
Meillä on Tapojärvellä useampi kehityshanke menossa tällä hetkellä, jossa tutkitaan eri kiertotaloustuotteiden mahdollisuuksia kaivosteollisuudessa.
Mitä enemmän me pystytään hyödyntämään kiertomateriaalia, niin totta kai sillä on vaikutusta siihen, että vähemmän tarvitaan sitten niin louhia neitseellisiä materiaaleja.
Minun suuri haave on, että joskus kaivosteollisuus ja kiertotalous kuuluu tiiviisti yhteen. Me ollaan Tapojärvellä aina oltu rohkeita kokeilemaan uusia asioita ja tekemään asioita järkevästi ja tehokkaasti. Ja me koetaan, että teollinen kiertotalous tulee olemaan valtavassa roolissa koko maailmassa tulevaisuudessa.
Maailma tarvitsee kestävää kehitystä. Maailma tarvitsee digitalisointia, sähköistystä. Siihen tarvitaan raaka-aineita, siihen tarvitaan mineraaleja. Kaikki, mitä vain pystytään ottamaan kiertotavarasta irti, ne täytyy ottaa uudelleen hyötykäyttöön.
Ja toivon, että omat lapset sais asua semmoisessa maailmassa, missä itse on päässyt asumaan. Että on ollut puhasta ilmaa, mitä hengittää ja on voinut järveen juossa uimaan. Ja jos nyt ei yhtään tähän panostettaisi eikä teollista kiertotaloutta olisi, niin aika synkät olisi tulevaisuuden näkymä. Mutta toisinpäin käännettynä taas, että jos me panostamme tähän, niin kyllä meillä on mahdollisuuksia taas jälkipolville jättää paljon parempi maailma.
Me halutaan jatkossakin olla teollisen kiertotalouden edelläkävijä.
Now it's time to start the actual challenge. Here on stage we have group number 1, Team React. Good luck.
Okay. So, do you know activated carbon? Activated carbon is a powder with high porosity, making it an excellent microfilter to either water and air purification. And recently, it has even been used to make supercapacitors, which are nothing else but the energy storage devices of the future.
And do you know about fly ash? In our case, it is the ash that is being generated by power boilers when burning the wood residues. Tapojarvi's partner, UPM, is producing more than 200,000 tons per year worldwide and is now being used in a not cost-efficient way.
Good afternoon. We are React, a team of chemists and engineers. We have developed solution in the activated carbon field. And today we're going to explain to you how we intend to use our knowledge to help you develop this field and to become one of Finland's major activated carbon producer.
So our process starts with two waste streams from UPM, 2-to-1 ratio mixture of wooden waste and fly ash. After it goes to pulverization, it goes through pyrolysis, controlled thermal decomposition, which lays the foundations for the activated carbon production. After, we introduce the steam to activate the material and increase even more its surface area. Our process excels in its simplicity and environmental responsibility. It uses 100% waste streams as raw materials, enabling circularity and minimizing the impacts. It's meant to be implemented as a new processing line in the forest industry. Our method is well established and ensures a consistent result. The unique composition of the mineral composition of the fly ash enhances the surface area of our products and the yield, the efficiency of our process.
All of this is being led because the demand is growing more and more. It's being led by the water and the air purification companies. As the population is growing and the pollution is also being more and more produced, clean technologies are becoming more and more essential. Imports represent more than 70% of Europe's activated carbon, meaning that Finland's production would not only meet a need, but would also reduce the negative impact on transportation.
So having a very simple process, we're able to match the lower price of the market at around €1,000 per ton. We would require a €200,000 initial investment for the research and development, and to build a full industrial scale would be around €600 per ton, generating a net revenue of €500 per ton. So tons of fly ash keep being produced every year, and we have the solution to this problem. We have the market, and we have traction. If we want to make this happen, it's now time to react.
Well, thank you for your presentation. Mr. Camponi, do you have a question for Team React?
Yes, I have to admit that I am not an expert about activated carbon. So my question is, what is the difference between this innovative activated carbon produced by recycled waste and the traditional activated carbon that can be are traditionally used? For example, we use to abate organic pollutant in electrical furnaces, for example. So I think what is the added value of this product, of course, in addition to the fact that we use waste to produce it? Thanks.
So normally the activated carbon is produced by coal or other wood, types of wood, which are not necessarily so sustainable as our process. And also we are adding the fly ash to our process, which is another waste that would be incorporated. And the fly ash, the mineral properties, the calcium, the potassium, interact with our activated carbon, making it with a higher surface area. So with better properties, with better purification properties. So we incorporate two wastes into our process, and we have better properties than the normal one.
Okay, thank you very much. So when you write that the yield is 15% higher compared to compared to traditional activated carbons. Okay, thank you very much.
Okay, Mikko, your question.
Yes, thank you very much for the presentation. My question is regarding the baseline for the sales price. How did you come up with the figure 1,000?
So the price for activated carbon right now is around 1,000 to 3,000 euro per ton. And to facilitate the penetrability of the market, since our process is very profitable, we went for the lower price of the market, which would help us really penetrate and meet the customers.
Okay.
Does that answer your question?
Thank you very much, yes.
Lawrence.
Regarding the specification of your product, do you know if it's applicable to all countries? Do you know if there are some specific legislation, or is it something you can export everywhere?
So as we've seen, it has better properties. Our product is going to has to be developed. We haven't had it, so we don't know about the specification right now. But I don't know if you see what kind of application the activated carbon is usually used for, like smoke and water treatments. But we don't have any.
And also, based on the studies and the specific surface area that we can reach is higher than the usually found in the products. And it depends a lot on the application. It's going to be water, air purification, but we could, based on the properties and our process, we can reach the minimum specific surface area for the filtration.
Okay, thank you.
Henry.
Okay, thank you guys for the presentation. My question is related to your process and the costs of the process. You came up with the 500, 600 euro per ton, and I see that you have a pyrolysis process in there. Is there any other alternative methods to use than the pyrolysis? Because, as I understand, it's quite pricey.
Yeah, I don't know if we can see the slide right now. We have the breakdown of the cost right now. So I don't know if we can see it. Thank you. So this is a breakdown of the costs, and we can see that electricity for the pyrolysis mainly is the major cost we have. We don't have another way around it, but our answer to this, if we want to break down cost even more, is that the raw materials, so those wood pellets, those wood residues that come from UPM, we price them at the price they would be, how they would be valorized in the energy sector. So they're burning it right now to make energy. We gave that price to the wood residues, which is something we could also negotiate with UPM if they want to get rid of this waste. Maybe we can even cut down the price of this residue. But for the electricity, to answer your question, we don't have another way around the pyrolysis, and obviously we'll try to make it as optimal as possible.
Okay, thank you.
Well, thank you, Team React. While the second group is getting ready, we head up to Tapojärvi Mining Services.
Our modern life would not be possible without the raw materials extracted from the ground. Metals wouldn't exist without them. We wouldn't have minerals needed for industry, construction, and primary food production. The world's population is growing. People's living standards are rising. Recycling and the circular economy alone are not enough to meet the growing demand for raw materials. Raw materials must be extracted. That's why we need mines. At Tapojarvi, we're experts and pioneers in sustainable, ecological, ethical, and cost-effective mining. We minimize the environmental impact of our operations. Our tax policy is responsible, and we take care of our stakeholders. We use responsible supply chains. We don't tolerate corruption. We promote equality. We do continuous development work and research. We focus our expertise on developing existing mines and reclaiming those that have ceased operations. For decades, we've been an integral part of the production chain in many mines. We always customize our services and equipment to our customers' needs. Our own maintenance organization takes good care of our equipment and works close to the customer in all our mining locations. With our new and well-maintained equipment, we can work safely and efficiently. The Tapojarvi mine is the only phosphate mine in Western Europe and the largest open-pit mine in Finland. We're a seamless link in the mine's production chain. Our alliance combines the experience and expertise of two organizations. It creates operations that are safer, higher in quality, and more profitable. It enables us to improve continuously, develop solutions to future challenges, and respond to change quickly. The European Union aims to reduce dependence on imported raw materials and increase European production of battery minerals, among others. The Hannukainen deposit we own in Kolari, Finnish Lapland, is one of the largest known unutilized copper resources in Europe. The Hannukainen multi-metal mine would significantly increase the production and self-sufficiency rate of iron and copper in Finland. Thanks to innovations in environmental technology, Hannukainen would be the purest multi-metal mine in the world. We constantly put effort into development and research to find the best and most sustainable solutions for the environment. We operate in such a way that we don't endanger our employees, customers, the environment, the equipment, or property. Tapojarvi's operations are guided by a high safety culture and responsibility. Responsibility for safety, quality, and the environment make our work meaningful. Enabling sustainable, ecological, ethical, and cost-effective mining. Tapojarvi.
On the stage, we now have team number 2, Innovative IQ. The floor is yours, please.
All right. Thank you. Good afternoon. Thank you very much for this wonderful opportunity. My name is Ayodeji, and my partner here is Yang Jiwei, and we are here with an idea. We call our team Innovate IQ, and we are here to present an innovative solution which we feel is going to be valuable to Tapojarvi. And then for us to make this tell our story and make it entertaining and also interesting for you, we decided to give you a little animation to tell our story. Thank you. So our idea is how we bring two unrelated waste and how we bring them together to become something beneficial for us all. So as we know, the Finnish additive manufacturing industry is trying right now to be one of the global leading fronts in additive manufacturing. They want to be at the top front. But then they are faced right now with a very big challenge. And the biggest challenge they have right now is in the issue of getting the right raw materials. Because right now, what the raw materials additive manufacturing is either metals or polymer. And we know that it's expensive and also carbon emission involved. Also, down at the industry, in the industrial field, in the forest industry, and also in the steel industry, we are faced with also another challenge in how we deal with the waste, the steel slags and forest industry, and not putting them up in landfills. So because Tapojarvi is trying for circular economic solutions to this problem, we decided to bring an innovative solution to combine this waste together to become something of a good product, which we call a nanoparticle decorated steel powder. This material is going to be made by combining the ashes from the forest industry with the steel slag, and then we are going to combine this material to produce our NPDS powder for additive manufacturing process. And this idea we are bringing to you, it's so very good because right now the cost we only have to deal with from Tapojarvi is just getting the laser machine, transportation, and the labor cost. Because 80% and most of the processes that we are going to use for this manufacturing is already available. And the material we are supplying is strong, lighter, eco-friendly, and cheaper material for the industry. This material that we are supplying for additive manufacturing as can be used in this site industries. This is an example of a prototype of a car structure that is built from additive manufacturing. And also we have, this part can be used in different applications. We have a lab-scale prototype of our NPDS material here that can be produced using this material. This is a turbine engine. And then we offer our products. It's offering, I've discussed how we are using this waste into solving this big challenge, but we also offer, it also offers this important material that this is a very high-focused material. It means the industries that use this type of material, like the reactor industry, are willing to pay any amount for this kind of materials. They are very high-functional materials. Also, 80% of the production process to achieve this product are already available in the manufacturing process in the plant. So it means that most of our challenges are solved. Thank you very much.
Thank you for your interesting presentation. And this time we start those questions, starting with Mikko, please.
Thank you very much, guys. Very interesting indeed. I'm curious to know a bit more about the kind of the market environment. So can you explain a bit what kind of players are there in the market at the moment who are providing the similar, or are there any other players that are providing this kind of option?
Thank you very much for Jerry. So I'm here for all the technical related problems. So actually this NPDS or ODS, depending on which nanoparticle you use, is now like the cutting edge of the 3D printing industry. So we would say like no people in the market, at least from what we have previewed, there was no people produced such type of powders. So as a material scientist, we also received the fundings from 2 years ago from the German government to intensively investigate such type of material. So I can only say like this is like a future gate. For now, we probably would be if we had a chance, then we probably would be the first player on the track. Yeah, thank you very much.
Thank you very much.
Then over to Lawrence, please.
Thank you for your presentation. Very nice and educative from the movie part. My question is that you say it's rapid prototyping. How long does it take to do this part? And is it compatible with mass production? Because if you go to the automotive, is it?
Thank you very much for Jerry. So for this one, we took almost 1 day. So because we are using some like inbuilt, like it's not the professional 3D printer, it's more like modified by the laser. That's also the reason like during the whole processes, we use laser not just for pre-processing, we also can modify that for make it as some like preliminary 3D printer, so it takes longer. But if we use some the cutting edge technique in the current the LPBF, what they call the laser powder bed fusion, or DED, the the deposition and the directed energy deposition, then it will be quicker. So such type of sample could just finish within half of a day, but it can be still improved. I have to say that. Yeah.
Thank you.
Then Henry.
Hey, thank you for your presentation. You did very well. And for my question is related to raw materials. When you are scaling up this kind of nice idea, how do you tackle the access to all the raw material?
How do we?
Where do you get the raw material? Did you have any research of where do you get and how much there is available to do this product?
Thank you very much for Jerry for the this very good question. So this is lab scale. So meaning we are taking the nanoparticles and the steel from the providers. So if we had the chance, then we definitely would try to reach as we propose the waste and the slag from the mineral and the wood industry. But I think there were challenges from the laboratory, the lab scale to the mass scale. There were a lot of technique. Problem should be solved. For instance, if we put ash inside this, it eventually go to three aspects inside this stuff. One is nanoparticle, which enhance this type of the strength of this material. Another is kind of like the textures, like the cementite inside, and some are fundamentally still keep as a contamination. So how to reduce those the portion of the different phases? We still need to do the investigation. Also, because those raw materials probably varies from one to the other, then we need to do some modification in the very original production of this NPDS powder. So we're currently not so sure, but it was researching. So,
thank you.
Thank you. And sorry, in addition to what my partner has said, concerning sourcing the material, that was the whole idea of why the process we are using the Tapojarvi already installed process. So our plan is that this plant is going to be situated very close to a steel plant. And the only thing we have to, that is why the transportation cost from our idea is coming from. The only transportation we have to deal with is transporting the transportation issue we have to deal with is transporting the wood ash from the other industry. So what we are proposing is to use the waste, the slags already available in Tapojarvi industries, mining sites, to use it for this process instead of having to take them off for landfilling or other processes. We use them. Thank you very much.
Okay. And then one more question. Hello, Italy. I think you thought we forgot you, but here we are. Time for you to ask a question.
First of all, congratulations for the presentation, for the brilliant idea. And I was in particular impressed by the high value of the product that can be produced through this process. I only have a question about the environmental property of the products, because I know that our Tapojarvi partners in Italy have to do a lot of activities just to obtain the certification of the product, especially regarding the leaching properties. So I ask you if you have approached this side of the performance of the product, if you have made some considered in some way how is the leaching properties of the products.
Should I go? Thank you very much for the Jerry. So we actually prepared some page for the property of such type of materials. So in short, when we have the nanoparticle inside, majorly the mechanical or thermomechanical property got enhanced. So as people probably know that like when such type of steel or alloy under the very high load, you probably have the plastic deformation. And the origin is the dislocation. When we have those nanoparticles, it pins those dislocation, meaning it becomes stronger. So, but the point is also like when we move this to the like mass scale, then how this nanoparticle, or whether they are on the right position, whether they are on the right size, it need to be investigated. So probably on the first or second batches, the property of such type of material is not as what we planned. We can already, foresee that. But after several runs, after the tuning of the ingredient, we will gradually approach into the best of the cases. Yeah. And other thing else is the functionality. Then for now, we don't target on that. We simply just try to deliver some high strength, to enhance the material for now.
Thank you. I just, give...
Hey, thanks.
Yes, also and concerning the environmental factors you were bringing into the question, is that if it has any side effects when it's leaching properties. Yeah, because the idea of what we're doing is we're bringing in a product, and also it's also part of the idea of why we use the laser technique, because during the laser processing, we are removing some particles away from it during the laser processing of the material. So the particles that could be harmful into the air or during the leaching process are already separated during using this technology. Thank you.
Okay, thank you. Team number 2, Innovative IQ. While the next team is getting ready for their presentation, we are watching another video of an Tapojärvi employee, Mr. Markus Partanen, who is managing director, maintenance manager. And he has been doing his studies, finalized all of it while he's working in Tapojärvi, and he has been chosen as Alumni of the Year. Tapojärvi is actively supporting and encouraging people who want to finalize their studies, and furthermore, Tapojärvi is doing close cooperation with many technical schools and faculties.
Mun nimi on Markus Partanen. Työskentelen Tapojärvi Oy:ssä huoltopäällikkönä. Mun vastuualueeseen kuuluu lastauskuljetuskalustoa merikaivoksilla ja niiden kunnossapito. Lisäksi on muutamassa kehityshankkeessa mukana. Ehkä tärkeintä on se, että tietää ripauksen, että mitä se muiden ihmisten työ on ja minkälaista se suunnittelupöydällä ne asiat on ja miten asioita esimerkiksi mallinnetaan tai lasketaan. Mutta konetekniikka antaa hyvät valmiudet nähdä asioita teollisuutta hyvinkin monipuolisesti ja antaa hyvät lähtövalmiudet monen eri position työelämässä. Että mä näen tärkeänä, että ymmärretään niitä perusteita sillä taustalla, vaikkei kovin syvällisesti mentäskään siihen johonkin tiettyyn osa-alueeseen. Ei se aina aivan hirveän helppoakaan ollut, että kyllä ne illat vennyy ja useasti se päivämäärä tai vaihtui sitten lauantain puolelle, kun niitä koulutehtäviä vielä työstettiin loppuviikosta, mutta sillä on vaan raivattavaa aika ja sitäkin on kuitenkin päätetty, että se sitten pitää aika päämäärätietoisesti viedä sinne maaliin asti ne asiat ja kyllä siinä niin pitää sitoutua siihen koulunkäyntiin. No, kyllähän Tapojärvellä on niin aina satsattu siihen osaamiseen. Mun mielestä on erittäin tärkeää, että satsataan ja koulutetaan sitä henkilöstöä ja kyllä se meidän yksi sellainen voimavara on, että me tarjotaan sitä tukea työntekijöille ja sitten huolehditaan myös sitä omasta osaamisesta, että oli työssä sun työpositio ikinä mikä tahansa, niin kyllä sun pitää niin itsekin huolehtia niin pidät sitä sun ammattitaitoa yllä. Ja varmasti se, että saa asioita vielä eteenpäin. Ja kyllä niin itse esimiestyöstä mä tykkään ja ihmisten kanssa olla tekemisissä. Kunnossapito on erittäin haasteellinen, vaikea aihe ja joka päivä kun sitä pikkusen enemmän ymmärtää, niin tajuaa vaan sen, että kuinka vähän sitä ymmärtää. Eli se on niin tämmöistä jatkuvasti opittavaa uutta ja haasteellinen. Sen osalta on niin haasteet edessä, että tekniikka menee aivan hirveätä vauhtia eteenpäin, sillä tulee niin sähkö yleistymään. Meidän pitäisi pysyä siinä mukana. Paljon asioita, jotka kiristyy lainsäädännön osalta tai säädösten osalta. Kyllä ne varmasti haaste on, mutta samalla se on kyllä juuri tekee sitä asiasta mielenkiintoista.
The third group is already on stage. Welcome, Team Tailloop.
Yes, hello there. We are Tailloop, and we're here to present our bespoke service for circular water filtration within mines through the repurposing of mine tailings. So, within mining, there are many issues regarding water, as it is critical for every stage in the mining process, all the way from transportation to dust suppression. This complexity within the mines can lead to positive water balances, where safe disposal of the water is key, but also the opposite, we have negative water balances, where you then have to make sure you've got a constant supply and you're not taking too much from the environment. Our idea, as shown here on the right, shows that we're using material from the tailings, especially the clays and the silicates, to filter metal contaminants and organic reagents, as well as small particulates from the water. That comes from the tailings pond and the processing facility. This water can then be safely disposed of or recycled back in to be directly used within the plant. Now, to show that this idea actually has some scientific foundations, we did some preliminary tests. So we mixed some clays with a solution of iron, and as you can see, it went clear as it was able to remove up to 95% of the iron. In addition, using the silicates as a kind of sand filter to remove fine particulates, we were able to show that passing water deliberately contaminated with clays through the silicates was able to make it much clearer and remove the small particulates. So that's the idea, but what is our bespoke service? Our service is bespoke, as we will help with the mine install, monitor, maintain and replace the filters. Through this, we can say we are flexible and collaborative, as we will work directly with the mines to implement our filter technology to their systems that they already have for pumping the water. We are also sustainable, as you can see, we are both reducing the amount of tailings on the site, the solid waste, but also the water waste and the potential mine water. And from this, we believe that in other ways, in environmental and safety aspects, we outperform other constant filtering technologies used, such as active and passive filtering technologies. As you can see, there is a huge active market that we could tap into. If we assume that half of the mines in the world are metal mines, this has a potential market for mine water filtration of 800 million euros. If at least 2% of these mines have the required amount of clay in their ore, which we believe is 5 weight % or less, this will generate a market of 32 million euros we could penetrate into. And with it growing really 5% every year, we can expand into this already expanding market. Our idea would be to originally look at customers within Scandinavia, such as the Boliden-Kevitsa mine shown here, but then to expand into Europe and globally with mines with more complex water needs and different sizes. So finally, we've done a financial assessment on a potential large copper mine example. And as you can see, it would, for our clients, the mines, it could improve their NPV by up to 160 million euros over 30 years. And as a company ourselves, Tailloop, we could have a potential NPV of 38 million euros over that same time period, with a quite short payback time for investors of only 1 to 5 years. Thank you very much for listening. We are Tailloop. We are flexible, collaborative, and a sustainable mine filtering technology. Thank you.
Thank you, Tailloop. Mr. Camponi, do you have a question for the team?
Yes, congratulations also to this group for the brilliant idea. I was impressed, but in particular, I think that it is crucial to the possibility to export this type of technology when implemented to the area of the world where there is more scarcity of water, more scarcity than in Scandinavia. And the question is regarding the efficiency of removal of pollutants. If the 50% is considered cautious, or is enough to assure the complete recycling of water? How they have calculated the efficiency removal of the 50%?
Okay, so to answer your first question, we have discussed potentially exporting our technology to areas that might have different water needs. However, in the first instance, we would be looking at a mine with a positive water balance, where we're looking at safe disposal and discharge of the water to the environment. So that's our first use case. We believe, based on some calculations that we have done, that 60% would be sufficient to meet the requirements for, we use the EU water standards. And we're currently working on a process of optimizing our procedure. So we're running some pilot studies based on our first prototype.
So adding her answer, because of 60% efficiency, we need to change our filter every 3 times in every 5 years. But based on our calculation, that is, we have sufficient amount of clay and silica in mine tailing, so I think that is possible. Thank you for your question.
Okay, thank you very much for the reply. Thanks.
Mikko, your question, please.
Thank you very much, team. Very impressive approach how to formulate the market size. And regarding that, have you discussed with any potential clients regarding your price point?
So speaking of price, we considered our price as 0.15 euro per cubic meter of water processed, which is a competitive price compared to other active filtration system that would cost more than 0.3 euro per cubic meter of water processed. And that is the baseline scenario. So depending on the complexity of the mine and operation, we can change the price. Furthermore, by choosing Tailloop filter, we can provide the safety, environmental, and societal values to the mines. So I think that is the significance of our filters. Thank you.
Thank you very much.
Lawrence, do you have a question?
Yes, thank you. Thank you for the presentation. My question to you is, what do you do with your waste? Because you capture heavy metals, do you plan to valorize that?
So we have a couple of ideas to what we do with our spent filters, because they do need to be replaced and then they won't work forever. So initially we have looked into researching what can be done with geopolymers and glass ceramic uses. There is evidence to suggest that the heavy metals won't leach out, but when we've tested this process, if that does not prove to be the case, we have also looked into the leaching of the heavy metals, because they will be very concentrated. We think there is potential economic value in those heavy metals, and they could potentially be sold back to the mine for leaching, or that could be a process we work on ourselves as a company. So we think there are different potential value propositions for the waste.
Thank you.
Henry.
Okay, thanks guys for the presentation. My question is related to the initial investment. I see there is a good market. You have calculated the euro per cubic meter cost, but what would what is the start investment to start to produce those filters?
A very good question. Thank you for your question. We calculated that we would need about 750,000 euro to run our company for first 2 years, and also to make first 2 filters for our first 2 customers. Do you have anything else?
I think the initial startup costs are mostly the filter casings, because the materials will obviously be sourced directly from the mine itself. So we've taken into consideration the manufacturing costs for those casings, which will be built into the infrastructure of the processing chain. So they don't need replacement like the filters do, and also the research and development costs.
Okay, I have one more question. Would you invest your own money, 750,000, if you have opportunity?
Well, we have some limited resources for initial sort of lab scale tests. However, in order to scale up our design, we would need external investment.
Okay, thank you, Team Taylor.
And as it is already pretty clear that we are working this occasion together with EIT Raw Materials, and the next video will show their capabilities and performances. And now on the stage we have team number 4, Waste for Waste. The stage is yours.
Thank you. Esteemed audience, welcome to Waste for Waste, where waste problems require waste solution. Now, let's start with the problem, or we see it, the green opportunity. Finland forestry and paper mills has been producing above 100,000 waste of hazardous materials, which includes green liquid dregs and bio-based fly ash. And also, on the other hand, our friends in the mining industry has been struggling with 72 billion problems of sulfidic gang material. Combined, you're looking at north of $100 billion market size that grows annually at the rate of 8%. Now enter Waste for Waste. Our product is simple, yet revolutionary. We combine the naturalizing properties of green liquid dregs, also the strengthening properties of bio-based fly ash. Together, they create a robust sealing layer that can prevent acid mine drainage. The mixtures is 7-part gang, 2-part dregs, and 1-part fly ash. This is a pilot project that has been done in Sweden since 2015, and it's been looking very, very good. Now, what is the benefits in our technology? we're not only trying to save the environmental here, we also want to reduce the cost and the risk that was normally used, features that was done in current industry, which is water cover and calcite treatment.
So thank you, Nathan. Now let's talk about business. Tapojarvi is strategically located between paper and pulp and mining industries. The target customers include Finnish market, which are Boliden Kevitsa mine, Terrafame, and Sotkamo Silver. Based on our calculations, the ratio of waste treatment just for these three companies already achieve 4.5 million tons, which already provides enough possibilities to sell. Our expenditures, main expenditures are related to transportation and equipment, but how will we make money? Through the subscription model. According to our estimation for Boliden Kevitsa mine with a covering area of 50 hectares, subscription reaches up to 15,000 euros per month. So the strategy includes funding and assessment during the next year, pilot plant escalation by the end of 2025 with the first commercial production in 26 and further global expansion by 2035. So why waste for waste such a great opportunity to invest? First of all, we maximize forest waste through circular economy while treating mining waste. Secondly, high TRL of 6 to 7 allows you to rapidly enter the market. Last but not least, you will have a continuous revenue stream due to the huge market potential. And this is our team. Thank you. Your questions, please.
Thank you for a very interesting presentation, and time for the questions. Be prepared for it. And starting with Mikko.
Thank you very much, team. My question is regarding the layer and how solid it is. So as we know, it needs to be very solid. So how have you considered how do you actually monitor and measure that the layer is functioning?
Yeah, I can answer that. Yes, that's why we are using the fly ash as a strengthening materials, because it's a very good cementitious properties and it's combinations to create a strong, robust layer that can withstand the soil and till that we're gonna put up top the sulfite mine waste. And yeah, what we have learned from that has been done in the prior project, the layer does compress a little bit, but it does not reduce these chemical properties and also the physical properties of the layers.
Okay, thank you very much.
Okay, thank you. Over to you, Lawrence.
Thank you. Thank you for the presentation. I'm not a mining engineer, so I wonder, how do you put in place this barrier?
Sorry, can you repeat it?
How do you put in place this barrier?
Yes, it's just commonly like casting building materials, where you just cast, first we mix the layers, the gang materials, the drags, and also the fly ash, we mix them in a mixer, and then we just cast above the sulfite mine waste. So it's just casting like we usually do in buildings through the mixer. Yeah.
And then Henry.
Yeah, thank you for the presentation. It seems like you have a quite good idea and there is some money still there. What are the risks? What do you think are the biggest financial and technological risks in your idea?
Yeah, so I might start at least. Yeah, first of all, the risk is with environmental licensing, because we know that we are in Europe and it's quite harsh to achieve it. Plus, the technology is still new, so there might be lots of, how to say, like, hesitations about its implementation. And regarding the cost, honestly, we don't have any problems with this, because we basically take it for free, and we can even pay this subsidization to paper and pulp industry. So yeah, I would say that for Tapojarvi, it's such a good service that you can add to what you have now.
maybe I can add a little bit about the technological part. I mean, in theory, it can the layers can withstand more than thousands of years. But yeah, it's still in pilot project, so it's going on into the 8th years now. They will try to open up the mine site and see how does it respond through weathering and all those kind of stuff.
Yeah, and one more moment. We didn't mention it in the presentation, but we also included it before. This technology is valuable preferably in this climate. So if you go to Spain, it might not work, but so far, it's good.
Thank you. And one more final question from the jury. Mr. Camponi, please.
Yes, thanks. First of all, congratulations for your presentation. And my question is that if you, in order to expand your business, if you are considering, in addition to a geographic extension of the market, for sealing layer for landfill or other type of application. Thanks.
Yeah, yeah, it's very geographical and also mineralogical specifics. So that's why we cannot say every mine will. We can have this one composition of 7:1 for every mine. It's gonna be different for every mine, and we have. That's why we in our projects we try to have 1 more year or 1 year just to see how the chemically reactive is the sulfide waste there, and also what additional stuff that you can add to the mixtures that will have the same properties that will give the same results to all the mines, the mines in the area. So right now it's in Sweden, but in Finland, if this project will be pushed forwards, we will try to look at the mine waste there and see what we can do through that.
Yeah, please also let's remember that all future potential mines are only in Nordic countries mainly. If we talk about Europe.
Thank you for your good work, team number 4.
Okay, thank you. Thank you.
While the last team gets up on stage, let's see what is going on with one of Tapojärvi's biggest projects. We are aiming to reopen an old iron ore mine in Kolari, Lapland.
We are dependent on metals. We need them to build a better future, to evolve and to develop solutions for a green transition. That's why we need mines, now and in the future. Iron, copper, and gold are essential raw materials for a modern, ecologically sustainable society. In the Finnish Lapland, in the Kolari municipality, in the old Hannukainen mining site, we have one of the largest unutilized iron and copper resources in Europe. Reopening the mine will significantly increase the production and Finnish self-sufficiency rate of domestic iron and copper concentrates. We are a 100% Finnish mine. We are owned by the Tapojarvi, a Finnish family-owned business and an international pioneer of industrial environmental actions and circular economy. That's why we have the best expertise in Finland and are making our mine the world's purest multi-metal mine. We are committed to responsible and sustainable operations regarding nature, people, and the economy throughout the life cycle of the mine, including the closure process. We are boldly developing new and safe solutions, services, and practices that can be utilized in mines around the world. We will ensure that our activities don't cause damage to nature's biodiversity during or after mining. We develop, research, and test water treatment solutions for as long as needed to be certain that the discharge water from the mine is not harmful to the environment. We constantly monitor the state of the surrounding nature both on and off the mining site. We can continue enjoying the clean and bountiful nature now and in the future. We respect and listen to our stakeholders. We engage in a fact-based, open, constructive, and continuous dialogue. We take into account other sources of livelihood in the area. We believe that mining, together with tourism, will strengthen the vitality of Lapland and Kolari. We create long-term, permanent, year-round jobs for hundreds of people and enable regional development, Shared prosperity is our goal. Responsibility for the environment and people is what makes our work meaningful. We are a pioneer in responsible and sustainable mining. Hanokainen Mining, Kolari Mine.
Hello, recycler. So, regarding our concerns, since 2017, my colleague and I started working on how to recover low-grade valuable metals from tailing using novel nanoadsorbent. But this will also has its own residuals. So we've been investigating how these residuals could have other applications. That's why he focused on recovery thing and I focused on zero-cement backfill in our PhDs, which both together might address two main challenges here as a system. We are recycler, which stands for recovery by environmental, social license, cost-effective innovation for circular economy of raw materials. So for Tapojarvi event, we focused on Hanokainen as a good case study that recycler could work there as a system because Hanokainen has low pH wastewater, 130 micron in tailing, and also good grade valuable metals. So plus forest industry side stream that Tapojarvi might be dealing with altogether let us know that tailing and waste from Hanokainen plus nanomaterials that we have synthesized in lab will result in valuable metals, cobalt, tellurium, LREs, and the residuals of this system will go to be added to fly ash, which will work as the binder, which is zero-cement backfill that we have designed and back. So this presentation should be zero jargon, but we just brought it to say that we have calculated everything in detail and it is not a fantasy dream idea. So here you can see that there is no need for exploitation, no need for crushing, no need for freshwater and acid, no need for cement. So we will eliminate around 30 kilogram per ton of CO2, which leading to zero carbon. And here you can see we will reduce toxic elements, we will produce CRMs compatible to Kolari climate condition, also reducing tailing and waste and utilizing fly ash as the binder. Here the market segment from penetrative market, which is Hanokainen, to potential market, which is Europe. And this is the stage development. We are now on TRO 5. And this is the rest of TROs that will cost around $8 million and it will take 48 months. Here you can see revenue. It will be positive after 4 years. And this is the estimation for costs and incomes. This is the business model. So the main resource income will be selling cobalt, like cobalt and other high-priced metals. And economy of scope tell us that costs of producing all these elements together, which will be much lower than producing each of them separately. Economy of density says that in northern Finland there are lots of similar dams. And also we cut off the cost of cement for around 75% of backfilling costs, and perfect for company branding. Thank you.
Thank you, team number 5, and time for questions. And starting again with Mikko, please.
Thank you very much, team. I need to say that was like a machine gun pitching there. What would be the first thing to do if this project would go further?
Well, you know, we want for TRL 6. We should make a comprehensive study on the real samples of Hanokainen, different samples from wastewater, tailings, and then we can choose the best nanoparticles with the best modification, with the best and most compatible functions for absorbing cobalt, different complexes and cations, and then we should design the zero cement backfill according to the residue of the adsorption process. You know, it's a multi-stage procedure. First of all, we remove the background noises such as heavy metals, and then we adsorb cobalt using nanoparticles, and then we can use electrosorption method for recovery of tellurium, or even using different nanoparticles with different functions for REs, especially cerium and lanthanum. and then the residue of my process will be get to the Fatima process, which she wanna design a specific composition for the zero cement backfill, which she use a combination of fly ash or even dust from steel slag, and in combination of the frozen specification and climate of the colliery location, and so it's all the job that we want to.
I would like to add that, as we said, it is a system. It is not just an idea that go in a way. So it is a system. It is like connected to each other. And the point is that what we are saying here, we have done in lab for several years with different samples. And now we're going to go to get real samples from Hanokainen. We have real, like what I'm doing in my PhD, I have real samples from a mine in Canada, and he also has the same. So now we're going to get Hanokainen sample to apply this system into this mine.
It's worth mentioning, we did a bench scale for iron mines, real samples of iron mines and gold mines with this system, you know.
Okay, thank you very much.
Then over to Lawrence.
Thank you for the presentation. You mentioned cobalt as being the first element to be sold. Have you estimated the cost of producing this cobalt versus primary sourcing?
The cost of producing cobalt, yeah. We have an estimation of the price of nanoparticles, and moreover, as we mentioned earlier, there's no need for acid or acidic water. As you know, we want to make a solution of our of the tailings, and then we need the cations of cobalt, which will be dissolved in our solution, and then we use our nanoparticles, maybe around $3 to $10 per ton for nanoparticles, and then for pilot scale, and then for you can say about your estimation of your process.
Yeah, it is in one of our slides, but generally I can say that it depends on the fly ash producing cost. But like in what I'm doing now in my project, because I'm using the waste of processing plant and it doesn't have any cost exactly to that company, so the binder, the fiber-based binder will not have any cost, so we just need to add them. That usually in processing plant you can find the similar facilities. So I can say that overall there are some costs, but it's not very like considerable. But we can check the slide.
It is worth mentioning, based on our estimation and calculation, after 4 years from TRL6 to TRL9, it will be beneficial, positive in return. Yeah.
Okay. Thank you.
Then Henry.
Okay, thank you for presentation. I see there is a potential. I'm interested about your technology and more specified this absorting. Is it something new you came up, or is it the existing absorbing methods you are using in your process?
About nanoparticles, nanoabsorbents. Yeah. We synthesize more than 9 different nanoparticles. Most of them are based on magnesium because it is cheap. And it's environmental friendly and has a high surface area. And then we modified most of them based on the environment of the solution. For example, for Hanokainen, we needed nanoparticles and modification which can be used in acidic environment, so we can use different modification, and we try it in lab scale and bench scale. It's our method and our nanoparticles. It's not the commercial nanoparticles. And the zero cement backfill will be designed, we mentioned earlier in our diagram, the combination of the different tailings with different fine particles below 30 microns, in combination of below 130 microns, and then we can add some greater and bigger particles to make a stable backfill, and especially we can add fly ash and dust to play as a binder for our. Yeah.
Also about the color climate condition that I mentioned in the presentation, I would like to say that cement hydration usually is affected adversely by cold weather, so we thought that it is a very great place to use zero cement backfill. We omit cement, and we can also in the next stages we can check if it is possible to have frozen backfill, which I'm doing now for a mine in Arctic. So frozen backfill is also another idea that could be added to this, but at this stage just fiber-based zero cement backfill would work in that case.
It's worth mentioning, at this time I'm working on a real world samples from mine sites in UK with the similar method and similar non-adsorbent. We wanted to recover lithium from unconventional resources such as wastewater and geothermal water with the same method. Yeah.
And then there is one more question in stock. Mr. Camponi, please.
Yes, congratulations for this presentation. And I, as my colleague said before, one of the most relevant part is the removal of cobalt and the other heavy metals. So imagine that there is a yield, important yield of the removal, but some cobalt and other metals can remain in the product. So I think that when I see the, for example, possible application is the filling of shafts on the old pits. I ask you if you have gone into the possible problems regarding the release of cobalt after the use of the product, for example, in some critical application like filling of pits and the release to the soil.
Thank you. I should mention that we don't want to just remove cobalt. We want to absorb cobalt cation, and then we use a desorption process, and we recover cobalt, and then we convert the cation and this enriched solution of the cobalt to carbonated form of commercial cobalt. You know, our product, one of our product is buying cobalt, and you know, regarding the residue of my process, because as you know, there may be a lot of heavy metals or other problems in the residue of adsorbing and recovering of cobalt. We wanted to make it diluted, and then we wanna convert it to zero cement backfill, and we wanna use it in construction for backfilling or for dam wall or such a thing. And we tested it before, and it is environmentally friendly. Yeah.
Thank you.
Okay, thank you. Thank you very much.
Yeah, so cobalt, LREs, and tellurium will be one of the income resources of this project. We can then sell them, and it will provide money for the company.
Okay, thank you. Thank you, team number 5, and this was the last presentation of the day.
So we are about to start the voting. Judges rank all the 5 teams, and 3 of the best innovations will receive a cash prize of 15,000 euros. In addition, the winning team's innovation may be developed into a sustainable circular economy service or product at Tapojärvi. And also the audience favorite will be awarded. And now let's recall what today's innovations were all about. Dear judges and audience, it's time to vote.
And while voting goes on, we have some entertainment in the meantime, so that let us focus as soon as this duo has finalized everything, and they will perform nice music and singing, and they will perhaps let us know what they really want to show us. Please.
Mulla on ihan liian pieni takki, on juonut ihan liikaa. Mulla on ihan liian kylmä, on liian vähän aikaa. Mutta silti kahlaan eteenpäin. Mulla on ihan liian sekko fiilis, on liian vähän rahaa, on päässä liikaa vahajana, liian vähän sua. Mutta kun nää niin palat loksahtaa, teet saaren mun kaakseen, teen majan maailmasi sun. Teet saaren ja päässäni mun on Tyynin meri myrskylläkin. Mä oon hieman liian vanha sulle, sä oot liian hyvä mulle. Tiedän, mietin vähän liikaa jo vähän ja vähän. Kun oot siinä, on kaikki sopivaa. Taidan olla liian huoleton, tai ne vääriä on. Musta ruuheja puuttuu, tai ne hukassa on. Vaan ei jaksa enää kiristää. Teet saaren mun kaakseen, teen majan maailmasi sun. Teet saaren ja päässäni mun on Tyynin meri myrskylläkin. On riippuvainen riippumatto, on taivas mun katto, nauraa punaiset posket, kun minua kosket. Ja joka ele, kun ukulele rinnassa soi. Teet saaren mun kaakseen, teen majan maailmasi sun. Teet saaren ja päässäni mun on Tyynin meri myrskylläkin. Teet saaren mun kaakseen, teen majan maailmasi sun. Teet saaren ja päässäni mun on Tyynin meri myrskylläkin. Teet saaren. Thank you. That was our first song, and it was our signature song called Maja, that means shelter in English. And we are originally from northern Finland, and we compose and write our music here also, and we use Finnish as our native language. And that is the way how we express this world, how we experience, and also we hope that companies could find ways to build a more sustainable tomorrow for all of us. We really want to believe in that. And then we go for a little trip to Mars.
tavaroiden Jumala, siellä tavara taivaassa. Kuuletko minua täältä romujen vuorelta? Täällä nukutaan, täällä hukutaan. Anna hiukan armoa, mä teen avaruusalusta. Täällä on vaikea luovia, sun sydän on täyttä muovia. Siis pelasta, jos en kuluta. Jonain päivänä lieni raivaan. Jonain päivänä lennän läpi taivaan. Yli tunkion, kassaputkilon. Ja me laitetaan piste tähän farsiin. Ja me muutetaan marssiin. Piste tähän farsiin. Puli puli, sopuli, mukaantuu. Hei tavaroiden Jumala, tarvitko uhria? Sun glitter sydänmaan rinnassa näkyy jo hinnassa. Tää jo kuluttaa, pientä kuluttajaa. Me vaan löydään miksejä, et sais lisää kiksejä. On luksushaaveet särkyneet, vuotaa jo robotin kyyneleet. Tarvin karkkia, ja noan arkkia. Jonain päivänä pieni raivaan. Jonain päivänä lennän läpi taivaan. Yli tunkion, kassaputkilon. Ja me laitetaan piste tähän farsiin. Ja me muutetaan marssiin. Piste tähän farsiin. Puli puli, sopuli, mukaantuu. Ja me laitetaan piste tähän farsiin. Ja me muutetaan marssiin. Piste tähän farsiin. Puli puli, sopuli, mukaantuu. Mukaantuu. Mukaantuu.
And one last song for you to vote. Right? Yeah. All right. This is 3. Yeah. This is Maan Jussi, like John of the Earth, maybe if we translate. Älä anna koskaan muiden sulle kertoa, miltä maan pitäisi näyttää vuosisadan vaihteessa. Onko enää maata ja mulla kastelukannua? Seisonko turhaan saappaat kuivalla hiekalla? Hei maan Jussi, tuu opettamaan mua maan kiertokulusta. Jiha, jiha, ha, jiha, kuinka viljan kasvamaan saatas korkeana. Kuinka kivet portailla loistaa aamukastella. Hei maan Jussi, Jussi, Jussi. Hei, hei, hei maan Jussi, Jussi, Jussi. Iltaisin tuijotan mä niskat mutkalla. Kuinka tähti taivaan kuviot vaan roikku taivaalla. Onko siellä ketään tähtien takana? Osaisko tummat otukset herneitä kastella? Hei maan Jussi, tuu opettamaan mua maan kiertokulusta. Jiha, jiha, ha, jiha, kuinka viljan kasvamaan saatas korkeana. Kuinka kivet portailla loistaa aamukastella. Hei maan Jussi, Jussi, Jussi. Hei, hei, hei maan Jussi, Jussi, Jussi. Hei maan Jussi.
Kiitos.
Well, ladies and gentlemen, time for victory ceremony, cérémonie protocolaire. For one thing, I want to thank all the 5 teams, because there is space only for 3 on the podium. You all have done an excellent and good job. Good job, we really appreciate it. We will start with the people's choice. Team Tailoop.
There you go. Congratulations.
Okay, and then we continue. 3rd place. Innovative IQ, congratulations.
There you go. Congratulations. Yes.
2nd place. Team Recycle.
Where are you? Congratulations.
And then the most exciting moment. 10,000 euros first prize winner.
Congratulations.
Congratulations for all the winners, and then I ask somebody from the winning team to come here on the stage and give a speech.
Well, thank you. This is quite a surprise, honestly, because there was a good competition today, and we really didn't expect it. So a big thank you to the jury that was there today. A big thank you to Tapojarvi for organizing all of this. And thank you to Anna that was there to coach us. And really, I just wanted to say a little word about EIT also, because about 1.5 years ago, I was leaving to Portugal, starting a new master degree. I didn't know anybody. I was actually asking, what am I doing here? And then I met those students. We've been studying for 1.5 years now. We're in Madrid right now. And I think we're a real family, and this is also something like EIT brought to us. And as I said, I mean, look at where we are now. We are master's students, and this is so much more valuable than just a thermodynamic class, as I say it. So a big thank you for this, and yeah, thank you very much.
Okay, so thank you, audience here, all the students, jury, and everybody online. The next time we challenge students with circular economic innovations will be in 2025, the 70th birthday of Tapojärvi. So until next time, ciao, ciao.
Bye.